The Single Tracks podcast is brought to you by TPC, the Pros Closet. Spring is the perfect time to upgrade, and TPC has an industry-leading selection of new and certified pre-owned bikes, plus frames, wheels, and accessories. Each certified pre-owned bike is inspected, tested, and serviced, and every bike includes 30-day returns. Visit tpc.bike/singletracks and enter code SingleTracks40 to save $40 on every order over $200. That's the Pros Closet at tpc.bike/singletracks, and look for the link and coupon code in the show notes. Hey everybody, welcome to the Single Tracks podcast. My name is Jeff, and today my guest is Travis Tomczak. Travis is the Global Marketing Director at Forge+Bond. The company manufactures bike wheels and accessories using a lightweight material known as FusionFiber. Thanks for joining us, Travis.
Right on. Thanks for having me, Jeff.
So before we get into talking about FusionFiber, let's talk a little bit about carbon fiber and how that's used to make mountain bike rims in particular. How does the process generally work?
Yeah, so I mean, most if not all of the carbon composites that are in our space are typically a thermoset base, meaning that it's you have a carbon fiber textile mixed with an epoxy, a glue. And that's, that is how, again, the wheels, the frames, whatever, handlebars, they're all laid up that way and done with the epoxy is the bonding agent that then is, cured, hand laid, etc.
Okay. And so, when you're making something like a rim, you have like a mold, I'm guessing, right? And you inlay this carbon fiber, which is sort of like a fabric, right? It's like a textile type of thing. So what's the process like in terms of shaping that material into something like a carbon rim?
Yeah. So with a standard carbon rim, you're going to have to, the base material is refrigerated. Which takes quite a bit of energy. You have to refrigerate it. It has a shelf life. It comes out. It is in a big sheet, like a textile. You have to cut it roughly into that shape, and then it's laid up in pieces generally by hand. And that's often why most of it is done in Asia, because you need that labor.
It's very labor intensive.
That lower cost skilled labor to do so. And then it is, like you mentioned, put into a mold and formed, and it has one thermocycle, and hopefully that goes well. If not, then it is landfill, right?
Yeah.
So it's labor intensive, it is energy intensive, and obviously with many things, when you involve the more hands you get involved, potentially the more issues you can have as well. Obviously, there are very skilled factories at this too, right? We all ride carbon frame. Most of us ride carbon frame bikes that we love and work great.
Yeah. So when you're talking about that material, like sort of that carbon fiber fabric, you mentioned it needs to be refrigerated, which I guess a lot of people probably don't realize that. And also when you're laying it up, is it like multiple layers? Like, do you just put one layer of this carbon fiber material, or are you sort of layering it in to kind of get these like different properties out of the thing you're trying to make?
Great question. Yeah, you're going to layer it up, and it's, I'm not an engineer, right? But there are different theories on how you would layer up your carbon fiber, where it needs to be, and that generally creates your, whatever the ride quality is that you're looking for, stiffness, weight, compliance, etc.
Yeah. Okay. So, this process obviously has been around for a long time. I mean, bike stuff has been made from carbon fiber for a long time. I don't know the history about it, but I feel like maybe it was frames first that we saw, like probably late 90s-ish. But the process has been around, the materials have been around. What are some of the challenges associated with carbon fiber manufacturing as it sort of has traditionally been done?
Yeah, carbon fiber, I think we're roughly, I guess you'll quote me on it, but I guess it's probably been about 3 decades.
Yeah.
Yeah, and it's been done the same way. And the challenges, I mean, I kind of mentioned them a little bit before, but I mean, we've seen it go in stages, right? And originally carbon fiber was very expensive, and then obviously scales of economy and more factories and figuring out efficiencies and et cetera have brought that price point considerably, not all, in all cases down, but it has where an entry level road bike or whatever used to always be alloy or or another material. Now it is carbon.
Right. But
the challenges of traditional thermoset manufacturing is labor intensive. So again, that is why much of it is done in Asia. It has specific properties too, from a performance aspect that create challenges when specifically we're talking about, in our case today, we're talking about wheels of whether you're going to have to sacrifice something to get an end result. And then there's certainly the unfortunate sustainability, responsible manufacturing challenge of it. It is very dirty. It uses a lot of toxins. It uses a ton of energy. It is extremely wasteful. There's a lot of landfill scrap, and it lives for a long time. It's not biodegradable. So yeah, good points. And so carbon fiber too. I mean, obviously, I think the first thing that people saw it as being useful for was to make bike components lighter weight. And it does a really good job at that. And then it can be very stiff, but are there limitations in terms of the performance of it? Like, we've heard that you can kind of adjust the layups and things like that to get various like materials properties that you want out of carbon fiber. But I'm wondering if there are other performance limitations in terms of like the bonding materials and that sort of thing that carbon faces. Yeah, for sure. And again, speaking, this is on the thermoset traditional carbon side of where you run into these challenges. I mean, we've seen it. You can make alloy super light, right? But the reason why the world, for now at least, has moved, has thought that carbon is a superior material is its strength to weight ratio, right? And then the idea that it can reduce vibrations and things like that in the ride. Yeah. And I'll speak to wheels, right? Because that's what we're doing, and I don't want to pretend I know how to make a bike frame or anything like that at the moment. In the wheel aspect, like one of those things I mentioned before too was the challenges of manufacturing and using thermoset with a wheel. And we'll talk a mountain wheel. Like the attributes you're generally looking for is like you want a wheel that's going to provide you confidence. It needs to be durable, right? Yeah, can't break underneath it. It needs to provide confidence or control. So you want a wheel that tracks really well, right? And then you also want a wheel that is stiff. You want it to hold you up in the corners, and you want your energy transfer to, when you put it into the pedals, you want it to come out, right? Yeah. And that is a big challenge of traditional thermoset products, where you can make a wheel that is, often the term is used, the term that's used is compliancy, or a compliant wheel, right? And that wheel, that's often why you see the modern shape of wheels too out there. We use the term kind of a pancake shape, where they've become much flatter. And that's to get a wheel that is more compliant. So in that straight line rock garden element, you get the ride characteristic that you get is that, or you're targeting, is that it doesn't ping off of things. Yeah. Now you can do that in thermoset. You can get that wheel. Some of us may have ridden wheels that are, truly very compliant. For an example, the Zip Moto wheel. So that's a very compliant wheel in a straight line. And tracks well in that straight line. And then on the other side, you can make a wheel on the, like if we remember, previous generation, and even some current generation, again, thermoset, like downhill wheels, they're really stiff, and it has that shape that's like a deeper dish wheel, right? Because it needs to be really strong, and because those guys are putting a lot of torque on the wheels and then in the corners, etc. The unfortunate side of thermoset in that scenario is you can't have both.
Okay,
you get one or the other. So
yeah. And it's dictated by the shape, not the material?
No, it's both. So
okay,
if you want that stiff feeling, you got to go for the shape. If you want that compliant feeling, that is also by the shape, but that's due to the nature of thermoset.
Right. Okay.
So yes, it's you're limited from an engineering standpoint by the shape. Again, I'm not an engineer, so some engineer may argue some element of that, but for the most part, that material, a thermoset base, is going to drive you to having to use a specific shape or inspire a shape to get the ride quality. So what that means is, again, you can have a wheel that feels great, straight line, but then when you throw it in a corner, it's going to fold or flex quite a bit underneath you. Yeah. On the flip side, you can build a wheel that is very stiff and going to hold up in the corners. However, you'll get that pingy feel, which we've all probably felt from a carbon wheel as well.
Yeah. Okay. Interesting. So now let's get into FusionFiber and talk about how it's different from traditional thermoset carbon fiber. Let's start with the materials. What's different about the materials in a FusionFiber product?
Yeah. So this is the primary, one of a few of the primary differences. And then this is where it gets complicated to describe or for often it to understand, as it is still a carbon wheel. Okay. It is still a carbon material, right? And because carbon's been made the same way for 30 years, people are like, what, why, how? We are truly, to use a cliche term, reinventing the wheel. So the FusionFiber starts with a different matrix. Okay. So the base material still has carbon fiber in it. Okay. However, the bonding agent is in current FusionFiber is nylon. Okay. As opposed to epoxy.
Gotcha.
So then I mentioned that a thermoset material has to be refrigerated, has a curing point. That's because of the epoxy. Okay. Right? Our base material can sit on a pallet at room temperature and is unaffected and has no shelf life. Okay. And because of that, it actually, and hence our name, Forge+Bond, it actually goes through multiple thermocycles to get our end product. Think about it. This is a very elementary way of looking at it, but like if you take a plastic bottle and you heat it up, you can form it, right? Right. And then if you heat it up again, you can change its shape again, and you can keep doing that. Right. Right. So, and then if you think about like take your most basic Home Depot epoxy, like JB Weld, once it's set, it's set. Right. Right. There's no heating it up, changing it again. So that the difference in the base of with that nylon being the bonding agent as opposed to epoxy. Okay. Then what also makes FusionFiber is the process. And that is a really high-tech, advanced process that is primarily robotic. There are very few hands that are involved in the process. Basically, the tape goes into a specific machine that lays it up per a computer-generated program. So there's where that would typically take many hands to lay that up. We lay it up in what we call a radial cross-ply, and that affects the strength of the wheel, the ride qualities we're looking for. So that radial cross-ply is a bunch of like 45, 90 degree angles. And when it comes out of that machine, it is already in a circular shape. Then it goes into another machine. It is bonded. It is heated up again. So another thermocycle, and it comes out basically like sheet metal.
Okay. Yeah.
So you have a flat sheet metal shape that's in a circle. Then it goes into another forge. So over a mold and gets pressed down, heated and pressed down. And that becomes, you have half a rim at that point. You got to do some trimmings, which again, all the trimmings from at this stage get thrown into basically a wood chipper. And, that material that we call it chop is, used into other goods. Yeah. For Forge and Bond right now, that's a tire lever, but we also sell that material off to adjacent companies. We have aerospace companies and prosthetics and things like that where it can be used. So it's truly it is a circular product path. And then you do, so we've made one side of a rim, we do it again. And then we put a spoke bed in there and bond it actually together again using heat and pressure. And that's roughly a wheel.
Okay, cool. So yeah, I mean, it sounds like it's still the same carbon fibers that you're starting with. The difference is the bonding agent, the thing that glues it all together, that gives it sort of its shape. And then the other difference is that it's formed into a sheet first. Like you're not putting into a mold that is like, let's say the shape of a rim. You're not putting these like, flexible sheets of carbon and then pouring the liquid epoxy in. What you're actually doing is you're starting with a sheet that's already bonded. It's got that nylon and the carbon fiber together, and then you're actually shaping that sheet. Is that kind of a good explanation?
Yeah, that's pretty accurate. Yeah, we call it a tape. It basically does come on this spool, and that is already a carbon impregnated with nylon. And that's the material. That's it. Yeah. Again, like you mentioned, it's not like it's not done in the manner of how we mentioned before, like a textile where you do have the big sheet. You got to cut it all out. We have a tape that goes on a spool. It goes into this machine and cuts it into smaller pieces, and it is already in the shape of a wheel. It is, it is a circle. It's a donut. There's a hole in the middle, and the rim is on the outside. So it's not this massive sheet of carbon that we have to cut into multiple pieces. It's really efficient, and there's minimal waste.
Yeah. Well, so I mean, I guess we should mention though, a lot of carbon now is not hand cut anymore. I mean, people are using laser cut. They're using computer programs to kind of lay out sort of the shape to minimize waste. And also, so the process though is for FusionFiber is kind of like two parts, right? Like where you're making the rim is a different location than where this tape is being made. Is that accurate?
That's correct. Yeah. The tape, we get from a supplier in the U.S., and then it is shipped to Gunnison, Utah, Central Utah, where everything is manufactured.
Okay, cool. So what are the performance advantages then of FusionFiber over a traditional thermoset carbon fiber?
Yeah, so we touched on those ride characteristics of compliance and stiffness in the pluses and minuses there of what you can achieve with thermoset. With FusionFiber and a thermoplastic wheel, the performance aspects that you get is you get the best of both worlds to be on that ride quality of you get a damp wheel. So it works legitimately like having a damper in your rear suspension of your bike as well. And then we are able to create the shape we want and format the wheel to make it laterally stiff. And then also because of that micro flexing that the nylon provides, it is very durable. It is more impact resistant. Yeah. So you get mainly the things that most mountain bikers are looking for, a wheel that is more durable, a wheel that is more, to use the common term of compliant, provides confidence or comfort because it's reducing the vibrations, it's giving you more traction, and then the stiffness to hold you up and in the corners. Yeah.
Well, I mean, for me too, like I kind of think about the materials and like carbon fiber, that resin, once it's cured, it's quite stiff. It's quite, it almost feels brittle. And I think that's what people, especially when carbon fiber first came out in bike stuff, people were worried like, oh, how is this stuff fail? Is it just going to like shatter? And, again, the material, it feels like that.
I'm not going to say like it's brittle, but there is a different, so a thermoset wheel compared to a FusionFiber wheel, when they break, I mean, we take everything in testing, right, to its point of failure. And the response is different.
Right.
So that initial onset when I say initial onset, that's when the anvil drops and that's when the wheel has been technically compromised. The initial onset point for where we have tested competitive thermoset wheels, that wheel is completely toast.
Yeah.
I mean, and that's the scary part of generally riding carbon wheels.
Right.
Right. Yeah. And as mountain bikers, we've seen it. We've all seen the videos and seen that catastrophic failure. And that's all I think in almost every mountain biker, back of every mountain biker's mind of when they ride a carbon wheel, right? That this could fail and fail horribly.
Whereas the nylon material is like what you would find on like a saddle base, for example. They've been using nylon for years for that. And most of us can kind of imagine like, we know what a saddle base feels like. It's kind of flexible. Nylon's also used for pedals, the like composite pedals that a lot of people run. And so, is it like a similar material in terms of its chemical makeup, the polymer that you're using for FusionFiber, or is it tweaked a little bit?
You know what? I'm not sure. I got a feeling, my guess is probably not. I think those are probably way more plastic or nylon in those layups than what we're using. Again, because of the structural element that it needs, right? You need your saddle to flex way more than a wheel. But again, I don't know.
Right. And it's a polymer, and so it can be like chemically altered to give it those different properties, I guess.
100, you can have different percentages. You can also, because it is a polymer, it could be a different polymer, right? Like there are a lot of different polymers out there. So I don't know, but back to that failure point, the FusionFiber, when it hits, is hit that initial onset by the anvil, it just means that in our situation, it just shows that it was compromised. At times that still means that the tire is even still holding air. Yeah. And then we take it well beyond that and give it multiple more hits till we say that it's at its ultimate point. But that never, in my experience, has ever been to the point of absolute catastrophic failure, right? Like it's a cracked wheel that like, if you had to roll out, you can roll out. And in testing, been through that personally, rode a wheel off a drop, hit a square edge rock. And, this was before obviously a production wheel or whatever. And it lost tire pressure and as like, I'm going to see if this thing can do it again and rolled right off, hit the exact same rock in the exact same place. And the wheel and just kept rolling and rode the bike out for 2 miles on, with the tire was still on, but like no air, and it rolled. It was still round.
Wow. So is it more expensive to manufacture rims from FusionFiber from carbon? I'm looking at like a Forge+Bond 30 EM wheel set is like $2,600, which it's a slight premium over like say a set from Reynolds or Industry 9. So is it the performance that you're getting, or is it the manufacturing process that's more difficult? Like what's kind of the price difference between them? Yeah.
So, I mean, that's a great question. It gets asked a lot, right? And especially when we you don't have the half an hour to explain the difference between thermoset and everything. There is an initial, we are doing something that nobody has ever done before, right? And to our knowledge, making a hollow form out of a structural hollow form out of thermoplastic, we are the only ones that we are aware of that have done so. And there's quite a bit of investment costs in that, right? We have machines that are very, very, all this automated elements and the figuring out how to do it. These machines are really expensive and very rare. And so there's that cost. There is the U.S. manufacturing cost.
Right.
I mean, this is the cost of making something in the U.S. and paying people decent wages. And, that has an overhead cost, and providing benefits and doing the right thing, right?
Yeah.
That is there. And like we started the conversation, originally general carbon bikes were really expensive, right? So it takes time for things to grow and scale and to figure out the efficiencies and to overcome those initial investment costs and whatnot. So that's where it's at. You pay for an element of craftsmanship
right
there as well, right? Like when you talk about a lot of our competitors, you really break it down, the process and materials and those things are all the same, right? Like they're made the exact same way with roughly the same materials. You're paying for an engineering expertise and a quality that you presume is there behind X brand, right? And that's most consumer goods out there, right? Yeah. Why is X more expensive than Y? And it's often because there's a level of craftsmanship that's behind one or the other or technology, and that is also there with Forge+Bond.
Yeah.
You are paying for a level of technology that only we can currently provide. And that is not only the fact that it's recyclable, but there is a performance aspect to that.
Yeah. And made in the US. So for sure, all of that kind of adds up.
Yeah. And that's a big part of it.
So one of the selling points for FusionFiber is that it's recyclable. So is it like infinitely recyclable, or is it going to degrade each time you go through? You mentioned that Forge+Bond has tire levers, but could you take the scraps and turn them into a new rim, or do you need to kind of downgrade it to something like a tire lever?
So it's a complex question because yes and no. It is the material is recyclable. So like I mentioned in the process, when any trimmings that come from the initial raw material, those get chopped up. If a wheel breaks in testing or whatever, say we overheated it and compromised it or something, it does not go into landfill. It also gets thrown in the wood chipper and chopped down. Now those fibers have gotten shorter when we've chopped it down. So it cannot be made into a wheel, but for example, it can be made into the tire lever. It goes into other goods outside of our space that are technically more expensive. So it can be upcycled, downcycled, and there is a world where potentially you have a hybrid. You make something that is using both virgin material and part of this chop, the recycled material. So technically, it's up, down, and horizontal. So, and then you ask the question, is it infinitely recyclable? No, but the material can be recycled up to 8 times. Okay. So it can be heated, chopped, that tire lever can be thrown back into the wood chipper, made into another product. And it's just finding that end usage. Right. And then, most of these things, 8 times, right? Like that's well beyond our lifetime.
Yeah, that's, I mean, on par with other plastic materials, right? Like a milk jug, you can only recycle that so many times, and eventually it kind of reaches the end of its life cycle. And then also, I guess what we're saying too is because those carbon fibers are getting chopped up, that it's no longer like a structural material necessarily, unless it is like a smaller scale kind of item.
I guess yes and no. I mean, there are, again, I'm not an engineer, but I mean, straight up, you could make linkage.
Yeah.
So, there's things of that nature that could be made.
Yeah. Interesting. Yeah. It will be cool to definitely see the things that are made from that material. Or is there anywhere that people can recycle their FusionFiber rims currently? Can they send them back to Forge+Bond, or like what's sort of the process for that?
Yeah. So we do it all in-house. Yeah. If unfortunately something happened, and, we have a lifetime warranty, it's really an easy process. Just contact us and we'll take care of you. And yeah, you send us the wheels. We're obviously going to inspect it and learn from it and then throw them in the wood chipper.
Okay, cool. Yeah. And so, yeah, we mentioned that like failure of rims and damaged rims that people happen to break in one way or another. What is the process? Like, how are you guys sort of cataloging that? And what can you learn from a failure of a rim?
Yeah, it's a good question. I mean, to be honest, we're very new. Right. So,
yeah. Fortunately, not a lot of failures to learn from yet.
Yeah. Yeah. And hopefully never. I mean, in all reality, your failure rate should be, less than 1%, right? On your warranty rate. That's a warranty rate. And, obviously we do all our internal testing and we have some of the world's best athletes and stuff. So we go through stages of testing product to see where the limits on all sides, whether that's weight or strength and what's going to work. So in that process, we take things to failure, and there's a lot to learn there, right? And that's discovering of materials, new materials, different polymers, different layups, different rim shapes, different widths. If you take a look at the EM30 sidewall, that's a 4 millimeter thick sidewall, where a lot of rims are, half that.
Yeah. And that's good for reducing pinch flats, right?
Exactly.
Yeah.
And that's something we learn from testing and failure and riding.
Yeah. Interesting. Well, I mean, we've been talking a lot about, obviously you're representing Forge+Bond, and we're talking about FusionFiber, which is a material, right? Like it's not Forge+Bond's material. It's, I believe CSS Composites is the company that sort of, I don't know, what's the word? They make it, they designed it. FusionFiber. Is that the right?
Yeah. So CSS is a manufacturer, right?
Okay.
That's the easiest way to look at it.
Okay.
Kind of maybe another business example would be like looking at Gore-Tex a bit. So like FusionFiber is Gore-Tex. Right.
The material.
Yeah. So in that sense, and that's where FusionFiber is being used in numerous other places outside of bike wheels. CSS specifically, is bike wheels and Forge+Bond, but there's a lot of other spaces in automotive and motorsports and aerospace and that where this material is being utilized.
Yeah. Yeah. And other brands are using FusionFiber. We actually first saw FusionFiber in wheels from, I think maybe it was Revel or was it Evil? I know both of them are using FusionFiber. So like, what was the thinking behind sort of like licensing, or maybe not licensing, like selling the material to other brands versus creating like, a brand that's owned by CSS Composites?
Yeah, no, really good question. I wasn't there at CSS when the original business format was developed. So CSS is the manufacturer of Evil wheels, of Revel. And that's why, they're done with FusionFiber. Chris King as well. Now, I can tell you why Forge+Bond was created within that portfolio. Yeah. And that was basically Forge+Bond is the advanced, best way to put it is it's the advanced concepts group of CSS. So knowing the capabilities, I mean, FusionFiber, thermoplastics, like that is our expertise, right? Mm-hmm. And that is our only focus. We're not trying to be a hub brand or a bike brand or whatever else, right? Mm-hmm. We want to show the world and evolve the production of thermoplastics, and with our own brand that lets us do it how we want to do it, move at the pace we want to move at, go the places we want to go, and try the things that we want to try, right?
Yeah. And so you kind of alluded to it multiple times, I think, during our conversation, that for now, FusionFiber is something that's being used for bike rims, but potentially are there other uses, like, and in particular, like if there are other uses, do you need to like tweak the material or the process, or like what's kind of the path toward maybe seeing FusionFiber in things like handlebars or bike frames?
Yeah, I mean, the possibilities, I'm not going to say they're endless, but it's vast.
Yeah.
It's vast both from examples you just mentioned to, again, the amount of things we could potentially make out of recycle material too, right?
Yeah.
And the processes there are, some will be very, very similar, and some would be different. So I don't know exactly how to answer the question 100%, but the answer is certainly yes. Mm-hmm. I'm not going to. I can't mention exactly where we're going, but I've clearly alluded to things, and if you notice too, we do mention ourselves as a component brand, not just a wheel brand.
Right.
So
yeah, gotcha.
Certainly, wheels are our focus, and that line will be one of the elements that grows the fastest for us.
Yeah.
So stay tuned.
Yeah,
for sure.
Cool.
We are not just an enduro wheel and a gravel wheel brand. We will be. we'll have more offerings.
Yeah. That makes sense. Well, what is next that you can tell us for Forge+Bond? Are we going to see in the near future other wheel sizes or wheel options, or what's kind of like the near term plan?
Yeah, as I mentioned, we're targeted to be a full line wheel program. Okay, absolutely say that with confidence. So you name it, we'll have it for you. Mm-hmm. And the breadth of the line, from different categories to different entry points as well, the line will get significantly larger quickly.
Yeah, cool. Well, Travis, thanks so much for talking to us about carbon fiber manufacturing and how Forge+Bond and FusionFiber is kind of taking this to the next level and developing a whole new process. Yeah, definitely learned a lot. So thanks.
Yeah, likewise, Jeff. It was a pleasure. Thanks for having us.
Well, you can find out more about the wheels that Forge+Bond is selling on their website. We'll have a link to that in the show notes. And you can also check out some good information on their website about the process behind FusionFiber and how all of that works. That's all we've got this week. We'll talk to you again next week.